Out here in the outer solar system, far from the sun, you'd expect everything to be frozen, quiet, and dead. And then you look at Io. Because what NASA found on Jupiter's moon Io shouldn't exist. A tall, razor-sharp mountain rising alone from a flat volcanic plain, like a spike pushed up through the crust. Not a mountain range, not a chain, one impossible spire standing by itself. And the strangest part is this isn't a one-off illusion from a blurry photo. Multiple missions, decades apart, point to the same conclusion. Io is doing geology in a way we don't see anywhere else. And once you understand what's driving it, you'll realize why Io isn't just the volcanic moon. It's a warning about what gravity can do to a world. But to understand the mountain, we have to start with the engine. Io orbits Jupiter in a place that is basically a gravitational torture chamber. It's only about 350,000 kilometers above Jupiter's cloud tops, roughly the same distance between Earth and our moon. But Jupiter's gravity is on a completely different level. It doesn't just pull on Io. It flexes it. And Io isn't made of ice like many outer system moons. It's dense, rocky, and metal-rich, which means when it flexes, it doesn't behave like a snowball. It behaves like a stressed ball of rock being squeezed by an invisible giant. The first big clue that something was wrong with Io came in 1979, when NASA's Voyager 1 flew past Jupiter and spotted active volcanic eruptions on Io, plumes blasting material high above the surface. That was the moment Io stopped being a dot in the sky and became a world. Today, the numbers are staggering. Io may have around 400 active volcanoes across its surface. 400. Outside of Earth, no other body is known to erupt this frequently. Io is the most volcanically active place in the entire solar system. And that alone is weird because Io is far from the sun. Out here, sunlight is too weak to heat a moon into constant eruption. Outside volcanic hotspots, Io can drop to around minus 130 degrees Celsius. It should be a frozen rock. So where does the heat come from? Here's the part that makes Io feel like a machine. Io is being squeezed by gravity over and over forever. Jupiter's gravity pulls hard enough to stretch Io's body, but Io's orbit isn't perfectly circular, and that's crucial. Io is locked in a gravitational timing pattern with Europa and Ganymede. Their pulls keep Io from settling into a smooth, calm orbit. Translation: Io can't settle down, so Jupiter never stops squeezing it. Io's path stays slightly oval. Sometimes it's closer to Jupiter, sometimes it's farther away. That means the tidal pull changes constantly. And every time it changes, Io flexes. Not by a little, by a lot. On Earth, our moon raises the ocean surface by roughly half a meter on average in the open sea. On Io, Jupiter's tidal forces can raise and lower the solid ground by up to about 100 meters. Imagine an entire landscape made of rocks slowly rising and falling like it's breathing, except it's not water being lifted, it's the moon itself being bent. That flexing produces friction inside Io. Friction produces heat, and that heat has to escape. It escapes through volcanoes. That's why Io erupts. That's why it has lava lakes and massive plumes. That's why its surface is constantly being rebuilt. Gravity is pumping energy into this moon like a generator that never shuts off. Now up to this point, the story is already extreme, but it still makes sense. Squeeze a rocky world hard enough and long enough and you get heat, you get lava, you get eruptions. But here's where the title of this video becomes real. A world that's constantly cracking, collapsing, and flooding with lava should not be able to keep tall, sharp mountains. It should erase them. And yet, NASA's images show that it didn't. If you picture volcanoes, you probably picture Earth, a cone, a crater, a mountain built up over time. Io doesn't work like that. There's no clear Earth-style plate tectonic system shaping long mountain ranges. The crust is stressed, fractured, and constantly being reshaped by tidal forces. Lava often erupts from cracks and fissures opened by flexing. After eruptions, material falls back down and coats the landscape. Sulfur and sulfur dioxide can freeze and settle like frost, while fresh hot spots glow where eruptions have recently happened. The result is a surface that gets repainted and resurfaced over and over again. Scientists estimate Io can resurface itself on surprisingly short geological timescales, meaning old features get buried and erased, and new ones appear. So again, where does an 18-kilometer mountain fit into that story? One of the most iconic examples is often nicknamed Steeple Mountain because it looks like a sharp spire. But the real surprise is that it isn't unique. When higher resolution images came in, scientists realized Io has multiple steep mountains scattered across its surface, and some may rise as high as about 18 kilometers, roughly double the height of Mount Everest. And unlike Earth, they don't form neat ranges. They appear like lone wolves, isolated peaks separated by vast plains, as if they were created by local failures rather than a planet-wide mountain building system. That pattern is the clue. Because if these mountains formed the way Earth's mountains form, you'd expect chains, you'd expect regions, you'd expect a boundary where mountains belong. Instead, you get sudden spikes in unexpected places. So what could create them? Here's where NASA's newer close flybys mattered. In recent years, NASA's Juno spacecraft, originally built to study Jupiter, began making close passes of the Galilean moons. Juno flew past Io at extremely close distances, on the order of about 1,500 kilometers, and captured detailed views of terrain that looks like nothing else. And that's when the mountain mystery stopped being a curiosity and became a serious geological problem. Because the sharper the images got, the less normal the mountains looked. They weren't smooth, they weren't worn down, they weren't sitting in ranges. They looked like blocks of crust pushed up violently, then left there. So here's the best explanation scientists have, and it's strange because it flips what you think volcanoes do. On Io, volcanoes don't always build mountains upward. Often, they create the conditions that push mountains up next door. A region collapses as magma drains, as voids form, as lava lakes develop, as the crust breaks and sinks. That collapse creates massive stress in the surrounding crust. And because Io's crust is already being flexed and fractured by tides, it doesn't absorb that stress gently. It fails. And when it fails, it can fail upward. Large slabs of crust can be pushed up, tilted, and lifted into steep, towering mountains, not by building, but by breaking. Think of it like this. Imagine a sinkhole opens on Earth. Now imagine the ground next to that sinkhole doesn't just crack, it heaves upward into a mountain. That sounds impossible here because Earth's crust spreads stress differently, and erosion immediately starts sanding everything down. On Io, the rules are different. There's no rain to erode peaks into gentle slopes, no rivers carving valleys, no oceans. The atmosphere is extremely thin, so when a mountain forms sharply, it can stay sharp for a long time, unless it gets buried by new lava or shattered by new stress. And because the volcanic activity is uneven and tidal stress varies by location, you get localized events. One area collapses, another area rises, one region becomes a depression, the neighbor becomes a spike. A pit can create a mountain next door. That's why the peaks are isolated. They're not part of a global mountain building system. They're scars from local crust failure events driven by tidal flexing and volcanic collapse. And this explanation fits something else we see on Io. It's a world of constant rise and fall, not just lava and plumes, but the crust itself acting like a stressed shell that keeps breaking and resetting. Now here's a twist that makes this even more extreme. On Earth, mountain building is slow. Even when it's violent, the violence is a moment, and the mountain is the result of long processes. On Io, the tidal pumping never stops, so crust failure isn't a rare event, it's a repeating possibility. Which means mountains on Io may form, fracture, collapse, and be buried again and again over time. That's why Io looks young, not because it's newly made, but because it constantly overwrites itself. Old features vanish, new ones appear. Io is a moon that doesn't keep its history. It burns it. So why does this matter beyond one weird mountain? Because Io is the clearest example of tidal heating taken to the extreme. We hear about Europa and Enceladus and the possibility of life beneath ice because tidal heating can keep oceans liquid. Those are worlds where tidal forces might create habitable conditions. Io shows the other end of the scale. Io is what happens when tidal heating is turned up so high that you don't get a hidden ocean. You get a volcanic engine. You get constant resurfacing. You get a world where the surface is being kneaded by gravity, like clay. And if you're wondering why NASA isn't rushing a dedicated mission to Io, part of the answer is simple. The Jupiter system is dangerous. Jupiter's radiation environment is brutal for spacecraft, and the biggest missions on the way are aimed at the icy moons, because those are the places where we might find life. But here's the irony. Io might be the most physically active, visually extreme world in the entire Jupiter system, and we didn't fully appreciate how strange its surface structures were until we started getting these newer, closer views. So what NASA found on Io wasn't supposed to exist, because it breaks the simple story we used to tell. Io isn't just volcanoes. It's crust mechanics under tidal torture. It's collapse creating uplift. It's a landscape where a pit can create a mountain next door. It's a moon where gravity doesn't just hold things together. Gravity reshapes the world. And that's why that spire matters, not because it's pretty, because it's evidence. Evidence that rocky worlds trapped near giant planets can deform in ways that challenge our assumptions. So here's the question I want to leave you with. If a moon can be forced into this level of activity just by gravity, how many other moons and how many exoplanets are out there being heated, flexed, and reshaped in ways we haven't even imagined yet? Io might not be an exception. It might be a preview. And that one impossible mountain is the proof. What do you think we'll find when we finally send a dedicated mission to Io? Tell me in the comments. And if this changed how you see moons, hit subscribe right now. Because next week, I'm covering something even stranger, a discovery that NASA still can't fully explain. Trust me, you don't want to miss that one. See you there.